Okay, I'm about to go over a quick review of the test questions. Now, for number 1, as you can see, it doesn't equal anything. Therefore, it's simply an algebraic expression. So what do? We combine like terms. What do we have alike? 8x minus 4x. Those are our first like terms that we see. 8x minus 4x is 4x. So now we rewrite the problem. 4x minus 5y plus 3y plus 6. We ask ourselves, what are our other like terms? Negative 5y plus 3y. Negative 5y plus 3y is negative 2y. So we rewrite the problem again. 4x minus 2y plus 6. There are no more like terms, so there's our answer. For number 2, it does equal something. So now we're dealing with an algebraic equation. However, if we look to the left side, we see 6a minus 3 plus a. Now, 6a can be combined with a. 6a plus a. Whenever you have a variable by itself, the coefficient, or the number in front of the variable, is understood to be 1. So 6a plus a will be 7a. So now we have 7a minus 3 equals 11. Now we have a simple two-step equation. To get 3 to the other side, we do the inverse and add 3. So now we have 7a equals 14. Now you have a one-step equation. Divide by 7 on both sides. 14 divided by 7 is 2. So a equals 2. Number 3. When we see these parentheses and the number outside the parentheses, we immediately know to distribute. We distribute by going over, keep the sign the same, and go under. 2 times 3y is 6y. The sign is a subtraction sign. 2 times 4 is 8. Equals 8y minus 12. Now we have variables on both sides. So, we subtract 6y because we want to get the variable on one side. So we subtract 6y because that's the inverse operation. 8y minus 6y is 2y. So now you have negative 8 equals 2y minus 12. We still want to get y by itself. So we're going to move this 12 to the other side. To do that, we must do inverse operations and add 12. Negative 8 plus 12 is 4. 4 equals 2y. We have a one-step equation, and so we're going to divide by 2 on both sides. 4 divided by 2 equals 2. So, y, or 2, equals y. Now, I know I may be going a little bit fast, but you do have the advantage of pausing and also rewinding. Okay, number 4. We immediately see there's a variable on both sides. We want to get the variable on one side all by itself. So we're going to subtract 2x from both sides. Because 2 minus 2 is 0, that's the inverse operation. 4x minus 2x is 2x. So now we have 2x plus 6 equals negative 2. You have to understand your integer rules, because here we're going to subtract 6 to do the inverse operation. This is a two-step equation at this point. Subtract 6 on both sides. Negative 2 minus 6 is negative 8. So now we have 2x equals negative 8. This is a one-step equation, so we're going to divide by 2 on both sides. Negative 8 divided by 2 is negative 4. So x equals negative 4. Now, this is an absolute value equation for number 5. Students have very detailed notes on how to solve this problem. First, there's nothing to isolate, so we immediately look at what it equals. It equals a positive number, therefore, it's going to have two answers. So, we set up the equation twice. X plus 3 equals 12, and x plus 3 equals negative 12. And then you simply solve the equations. Right here, to get x by itself, we're going to subtract 3. 12 minus 3 is 9, so x equals 9. That's only one of the answers. The other answer, subtract 3 on both sides. Again, you have to know your integer rules. Negative 12 minus 3 is negative 15. So x equals 9 and negative 15. Number 6. You have to isolate everything away from the absolute value symbol. The only thing near the absolute value symbol is a positive 5. So to isolate it, we have to subtract 5 on both sides. Now, this is where the notes that the student should have come into play. 5 minus 5 is 0. So we have x plus 2 equals 0. Once they look at their notes, they'll see whenever the absolute value equation equals 0 after you isolate, there's only one solution. So this is the only problem we must solve. We subtract 2 on both sides. 0 minus 2 is negative 2. So that's our answer. Finally, and you're going to love this one, especially if you're the type to look at your notes. Because here, we're going to isolate away from the absolute value sign. To do that, we're going to subtract 14 because that's the inverse operation. 8 minus 14 is negative 6. So, if you're looking at your notes, you'll see whenever the absolute value equation equals a negative number, after you isolate, the answer is no solution. Because absolute value equation, once you do the isolation, cannot equal anything negative. So, there you have it. Those are the answers and how to work out all 7 problems. Students need to review these steps, understand these steps, and then they'll be ready for the retake. Thank you.